So let's start with the next project, that is ultrasonic sensor with the servo motor. So here we will be using an ultrasonic sensor. This is my ultrasonic distance sensor. So this sensor will send an ultrasonic sound wave, and when this sound wave will hit an object, this transmitter, you can see T and R. What is T means transmitter. Transmitter will send the ultrasonic sound wave, and that sound wave will hit a particular object, and then reflect back that wave. And this receiver, R represents the receiver. The receiver will listen the reflected wave, and based on that, calculate the distance from the object using the equation. And based on that, we will upload a program, and based on that distance, the servo will rotate. This is the basic working behind this project. So here in the ultrasonic distance sensor, there are 4 pins. One is VCC, then trigger, echo, and ground. So this VCC is connected to the positive terminal of the breadboard, and this ground is connected to the negative of the breadboard. And this there is one trigger signal and echo signal. So this trigger signal will send the ultrasonic sound wave from the transmitter, and this echo, this will receive the reflected signal from the object. And this trigger and echo signal uh, connected to the digital pins. You can use any pin. Here in this project, I used pin number 9 and 10. So pin number for trigger, I am using pin number 9, and for echo, I am using pin number 10. So this is the ultrasonic sensor. So we need an ultrasonic sensor. So HC-SR04, and a servo motor we are using. Here, this is my servo motor. Okay, so this is the micro servo. This is the micro servo, and this is a motor, and this position we can control using a microcontroller like an Arduino. So with the help of this Arduino, we can control the position of this servo. So this servo will rotate from 0 degree to 180 degree. So based on the distance detected by this ultrasonic sensor, the servo will rotate accordingly. I will show you the code. So this is the code. So these are the components required: Arduino, then ultrasonic sensor is required, then servo motor. Jumper wire is used to connect the servo, ultrasonic sensor, breadboard, Arduino, everything. So breadboard is for easy wiring. We can use breadboard. We can connect everything. We can connect the servo, we can connect the ultrasonic sensor, we can connect the Arduino with the help of this breadboard for easy wiring. Then 5 voltage power supply is required. Okay, so as I mentioned earlier, the ultrasonic sensor sends sound waves and measures the time taken for them to bounce back. Then based on that time, the Arduino calculates the distance, and based on that distance, the servo will rotate accordingly. If an object is detected within a certain range, the servo rotates to a defined angle. So this is the code actually. So here in this code, I have given three conditions. One is if the object is less than 10 centimeter, the servo moves to 0 degree. That means there is the rotation to 0 degree. And if the object is between 10 to 20 centimeter, the servo moves to 90 degree. And if the object is beyond 20 centimeter, the servo moves to 180 degree. So this is the servo rotation based on the distance. Okay, I will show you. I will click start simulation. So here in this, so this program is different. Okay. So in the simulation, we can see distance from 0 to 200, and the servo rotation will be 0 to 180. Okay. So here this circle represents the object. Okay. Now the distance is 253.8 centimeter, but in the program it is mentioned that 0 to 200. Okay. 0 to 200. So here the sensor is detecting the object, but the distance is 230 centimeter. So the servo is not rotating because in the program it is given that the distance is from 0 to 200. So if just I am shifting this object. Okay. So I'm shifting this object below between 0 to 200. Now you can see the servo is rotating. But if the distance is more than 200, the servo is not rotating. See, now the distance is 250, 240, 246, 240. So the servo is not rotating. Why? In the program, it is given that the distance is from 0 to 200. Okay. So when I am shifting the position of the object to here, so now the distance is 118. So you can see the servo is rotating from 0 to 180 degree based on the detection of the object. Okay, so you can modify the program accordingly. So this is the equation. Distance is equal to duration by 2 into 0.0344. So this is the this value 0.0344 is the speed of sound in centimeter per microsecond. So this is the duration. This is the duration of the reflected signal coming back from the object to the receiver. Why we will divide this equation by 2? Because first we will start with sending the signal to the object, and then we need the duration. We need the distance from the reflected wave only. Okay, so actually the sound wave is sending from the transmitter. Okay, and this equation is calculate the distance equals duration into the speed of the sound. Okay, why we divide this equation by 2 means we need only the distance of the what you call it, the duration from the for the reflected wave only. So once again, based on the distance given in the program, the servo will rotate accordingly. Okay, so this is the project uh, related to the ultrasonic sensor, servo, and Arduino with the breadboard. Okay, I'm going to the schematic view. This is the schematic view. This is the connection. Here, this is our servo motor, and this is the ultrasonic sensor. Okay. So in the ultrasonic sensor, there are 4 pins: VCC, trigger, echo, and ground. So this VCC is connected to the 5 voltage. Okay, this is the Arduino, and here you can see this VCC is connected to the 5 voltage, and this ground is connected to the ground. And this trigger is connected to the digital pin number 9, and echo is connected to the digital pin number 10. And coming to the servo side, there are 3 terminals: power, signal, and ground. So power is connected to the 5 voltage, and ground is connected to the negative, and signal is connected to the pin number 6. Pin number 6. So this is the connection diagram. These are the component list. We are using one Arduino Uno, and ultrasonic distance sensor also we are using 4-pin ultrasonic distance sensor, and a positional micro servo also we are using, and also one breadboard is also using. So if you want more information, you can visit this site. Go to projects and ultrasonic sensor. So the project overview: what are the components required to prepare this project, the circuit connections, okay, how you will connect, how you will connect to the ultrasonic sensor and servo with the Arduino, then the working, then this is the code. Okay, but in this code here the in this code, the distance is given less than or equal to 10, then move the angle to uh, my servo dot write 0. That means move this to 0 degree, and if the distance is between 10 and 20, then the servo will rotate to 90 degree. And if the distance is other than this value, the servo will rotate to 180 degree. So like this, you can modify the program accordingly. So the connection diagram is also displayed here. Okay, you can refer this connection diagram and connect accordingly. And what are the applications? What are the applications of this particular project? So the automated doors and gates. When, for example, when you will enter into a room, or when a particular car is enter into the parking area, the gate will automatically open. Okay, the sensor will sense the object, and based on that, the door or gate will open accordingly. Then another application is that obstacle avoidance robots. So there are robots. When the robot is moving in a particular path, if there is an obstacle is in the path of the robot, what happens is that the with the help of this sensor, the robot will sense that particular object and adjust its direction when detecting the object. Another application is that smart parking systems control barriers based on the vehicle proximity. So these are the applications related to this particular project, such as automated doors or gates, obstacle avoidance robots, smart parking systems. So you can watch this video, and also you can refer this particular website to do this particular project. Hope you understand the connections, the code, the uh, the simulation, the working, the connections, everything you understand. So try to do this particular project. Have a nice day. Thank you.